We're going to have a little look at hyperbolas. Now, hyperbolas, we know that linear equations are a function of y equals a to the power of x. Hyperbolas kind of borrow from this a little bit. They're in the form of xy equals k or y equals k on x. What do I mean by that? Well, you might be asked a question like graph y equals 1 over x. So that's the form. Again, let's just do a little table of values, x and y. I'll try and make sure I have enough little spaces here. Hopefully I do. So I'm going to start at -3, -2, -1. I'm going to say -1/2. And then I'm going to say 0, 1/2, 1, 2, and 3. Let's end it there. All right, table of values. Now, if I substituted x in for all of these values here, it'd be 1 divided by, well, 0. Here's the big thing. So I'm going to write a u there, and that u is short for undefined. Now, obviously, that's the case because we can't divide anything by 0, so it's always going to be undefined. There is no value. You cannot define that value because you can't divide by 0. Now, if I did 1 divided by 1/2, I end up with 2. I end up with 1 here. I end up with 1/2 there and a third there. Now, I can just kind of go back the other way and just say, all right, well, that's going to be -2. That's going to be -1, -1/2, and -1/3. There's my table of values. So I'm going to draw my graph here. I'm going to be careful to make sure I split this exactly in two, because you're about to see the main trait of a hyperbola. So I need 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, and 3. 1, 2, 3. Obviously, that's 0 in there. So let's graph this. I'm going to start at 0 and move this way. So if I was at x at 1/2, well, this is going to be up there at 2, right? All right. X is at 1. It's going to be at 1. X is at 2. It's going to be at 1/2. X is at 3. It's going to be even smaller again. So this looks something like that little line there, which probably should be a bit smoother, but you get the idea. So I'm going to go the other way here and graph it now. So again, I have x is at -1/2. That's at -2. X is at -1. It means that's at -1. -2 means at 1/2, and then here again. So let's graph this. Now, the thing with the hyperbolas is these two are going to be the exact same essentially. They're just going to be mirrored diagonally across there, as you can see what's actually happened with this table of values. So there's some traits, I guess, you can look at when looking at hyperbolas, and those traits would be, well, there's no value when x equals 0, obviously. It's going to remain undefined altogether. What else? What else can we look at? Well, the hyperbola actually has two different asymptotes. So how do I know this? Well, I'm approaching x equals 0 here. Oh, I'm never, ever going to make it. So I have a vertical asymptote here of x equals 0. Never, ever going to make it. And down here, we've seen this before as well. It's approaching y equals 0. It's trying to get there, trying to get there. So it also has an asymptote of y equals 0. That's the exact same for this one down here. Now, all hyperbolas actually have asymptotes of x equals 0 and y equals 0. So a horizontal and vertical asymptote of both. So as x gets larger, it gets close but never touches. And the same is true as x gets smaller. It's going to get close but never ever touch it. And this is known as a discontinuous graph, as in they're broken up. They're not one continual line. But a hyperbola essentially is the definition of a discontinuous graph. Now, I just want to show you one more thing. Now, I'm not going to do the table of values for this next one, but there's one more little thing that can make your hyperbola look a little bit different. So I'm going to draw up here just a basic idea of what our one before looked like. Whoa, that was not very good. I look like keep drawing it touching. It never, ever, ever will touch. Okay, so it's like that. And this one here was like that. So I'm kind of a little bit like that. It doesn't look too great, but here we are. So here you might get something like graph. Let's have a look. Y equals -3 on x. Now it says here for -3 x and 3. That's essentially saying for x is less than or equal to -3 and x is less than or equal to 3. So this essentially means you're going from -3 all the way up to 3. That's where you would draw your table of values for. So let's define that. Now, this graph looks different because of this negative here. And the way it looks different is it's actually going to just occupy these other two quadrants, essentially. It's like a mirror of this one up here. So when this top value is negative, it just means it's essentially going to mirror whatever the positive value is. So if this was 3 over x, it means it would look like that in some way, shape, or form. But because it's -3 over x, it's going to occupy the other two quadrants. That's it. That's pretty much hyperbolas in a nutshell.